The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, everybody. And this is Dr. Mansour, and today is March the 29th, and this is the transportation workshop during the summer period until we meet again in July. So I was here yesterday and I was teaching the AM, and everything went fine. But in the afternoon, for some reason, when I was teaching the surveying class, the audio was gone, and I tried to use my phone. It doesn't work. For some reason, the system yesterday was not really helpful. I hope that it will work well this morning, because there is a huge demand for this video nowadays. This and another suppliers or another vendors like Zoom and all these things seem that communication nowadays over the internet is the main um, uh, media right now everybody is using. So I hope that we will not have any issue this morning as yesterday's morning, and also this afternoon I have a seismic class. In fact, last time also I lost the connection for some reason. I was not able to come back, but anyhow, let's start. So I did my best this morning, came early. I tried to work with the system to make sure that everything is working fine. So today is the 29th, and from 9 to 12 I will be here. And the main objective, as I mentioned yesterday, from these classes, they are free. You can invite your friends, you can invite anybody you want, okay? You are very welcome to do that. Um, that is just to keep you keep continuity, because I don't like to lose whatever we covered, the 70% or maybe 65%, whatever you like to call it. But I believe we covered okay up to chapter 6, which is signalization. Chapter 6, signal design. We took the second half of this chapter, which is based on MUTCD, as all of you know, and we covered the signal warrants, the 9 warrants, and I hope that you get a chance to keep refreshing your memory about these things. So this is what we were stopped. And when I start over again, because I'm going to start here, we have about 7 sessions or 7 sessions. We are going to start in July. The course will start again in July. Those of you who enrolled in the class in the spring, for sure, they are going to attend again for free. So we're supposed to start July 5th. Okay, so July 4th is a holiday as far as I know, which is the 4th of July. The 4th of July, it came Saturday. So I believe everybody will get Friday off. But immediately after the 4th of July, we're going to start July 5th. I hope everything will be fine at that moment, and this coronavirus issue is over or became history. I hope so. Stay healthy, stay safe, and we'll do our best. So this is, and I'm going to start from where we stopped. So I will do my best, and um, um, I know Zoom is another avenue of communication. I can use it, but I have been using this company for the last 10 years or so. Zoom is trying, okay, to efficiently use, okay, resources. When you get a break, you should disconnect the video. When the break is over, log again. Then Zoom may not block your video. Maybe I don't know. I agree with you. I heard about Zoom and I used it once, but for the time being, I'm using this because my staff they are familiar with it, and the recording issue and converting the files and loading the files on the server. All these things are things that I'm looking for it right now, and my staff will evaluate that, and for sure we are going to pick whatever system is the best. But for the time being, since we are using this system, I've been using this for a long time, so I prefer to stick with it. I pay money for it because this is where the service is. I know Zoom may be free up to a certain limit, but I will do my best. I will do my best. Maybe Zoom it has advantages or has some additional feature that is not available in the current system I'm using. But I will do my best and we'll take it from there. Okay. So my advice to you: try to. Uh, you are telling me no voice. We lost you. I don't know why. The voice here from my end here is still working. Anybody lost me? Okay. Sam, great. You are loud and clear. So, Muhammad, you can get out and come back again. So everybody is on. So I hope that yeah. So I get the message that everybody because I have a message here. I have a control panel here from my end. So let's do our best and let us focus and whatever, because every media right now, Zoom or go to webinar.com, the one I'm using right now, everybody is using the internet. Everybody, as you know, is sitting home. So there is a huge um, um, huge use of the internet. So the internet maybe will not working fine during this crisis, and I hope um, that we will be able to communicate and we'll keep doing that. But I'm looking to the Zoom okay option as another way of offering these webinars. But for the time being, let's use the system and hopefully the system will work with us. Okay, let us do our best here and let us. So when we'll come to July, again, you already received these three books, the AMBM and practice exams and the textbook. There are a few things still missing in the textbook. I'm trying to complete them right now. The other book, which I promise you, I will give it to you. I will give it to you, but I dropped it from the fall semester because it's a repetition, which is a summary book. Summary book. I took all the equations and the tables and the charts from here and I put it in a separate book. So I found what is the benefit of repetition. So it is not really, but since I promise you or I announce it for the first time in the spring, I will send it to you. Okay, I will send it to you. But for the new engineers who are going to join me for the full course, these are the books that will be offered. And if the NCEES they come up with a new book, I have no problem. I will buy it and send it to you. If NCEES they come up with a new book to match the new codes, I have no problem with that. I will purchase it. I'm following up with them, or I'm checking their website from time to time and communicate with them by email. And if they come up with a new edition of the practice exam book or books, because they have the five, we will do our best. Okay, so this is a course for the fall, but for the time being, we are going to do these workshops during summer to keep continuity. Number one, I don't like you to forget what we covered, and keep working. If you like to um, continue watching the on demand, let me know if you have any problem with the on demand. The on demand is supposed to go all the way until April 17, which is the exam day, and after that it will stop automatically. But I will ask my staff. My staff are working also from distance. They don't come to the office anymore, so they, they are working from home, and obviously working from home is not as efficient as working in the office. So but we'll do our best to serve you, to keep you busy all the way to the end. Okay, So try to get the maximum benefit of this break, and hopefully that everything will be fine at the end of this crisis. And try to be safe, try to do your best, and I will do all my best too from my end here. Having said that, let us. So this is where we stopped last time. We talked about chapter 6, which is signal design. And we took the other half of this chapter, or the um, second half of it, which is the MUTCD 2009 about signal warrants. And I send you the like a flow chart for the signal warrants, but I've sent only for warrant number 1. I will resume working on the other warrants, but warrant number 1 is the one. It is a little bit a lot of parameters involved. So I hope this way of providing the picture that will help you to understand the condition A, condition B, and 100%, 70%, and or all these things we talked about it. And at the end, I provide a summary for the warrant number 1, which is the 8-hour vehicular volume. And I will keep improving whatever improvement I can make into my books. I have no problem with that. I will be glad to keep doing that. The exam number 1, which I send it to you, this is another thing that I need to resume writing mini exams. I call it mini exams. For example, like mini exam number 1. I don't know how many of you already solved it. I received only 1. I did not receive. I encourage you during the semester to work all the problems and send it to me, not just for it's not for grading or for anything like that. It's just to encourage you to work all these problems because they are a way of keeping you busy and enhance your understanding about. So I will resume the mini exams and start, in fact, last night. I'm doing all my best. Anytime I have, I try to improve or keep you busy, improve the product or the products I have, and also in addition to that, to keep you busy. And when we start in July, as I said, I'm going to start from chapter 6. So even for those who are going to join me the first time in the fall, we'll start from here and go to chapter 6 and 7 and 8 all the way until finish chapter 10, which is alternatives analysis. And after that, I will start over again from the beginning of the book. And in this case, you will have the choice to join me again, or if you prefer to sit and study and solve problem, this will be your choice. But I will start where we stopped because I don't like to repeat what I covered before. Especially it is available for you 24/7 through our on-demand. And in this case, you have a plenty of time to prepare or something like that. If anybody has a suggestion, I have no problem with that. Any suggestion that it will improve the product at the end, I have no problem with that. But this is what we discussed, I believe, when we met last time. So we will do our best and keep working. Um, um, uh, um, um, uh, okay. So the um, okay. So let's start. I got a couple questions. Um, okay. Uh, One of you is asking, what is a signal warrant? What is a signal warrant? Okay. What is a signal warrant? Okay. So the uh, MUTCD This is transportation, and also as we did before, I will be glad to scan these things and send it to you, and look at it if you find anything. So the what do you mean? You are not receiving any link. I don't send any link. Okay, I don't know what is meant by what do you mean by send any link. Please explain it to me. We don't send any link. Everything this is done automatically. We don't. If you are talking about these free webinars, the moment you logged in and add and join me, enroll in this. This is all what I am enroll once for all of them, unless I don't understand, John, what they mean by link. I have no. Please clarify this to me by email. I received one email from you. It has, I believe, 4 problems. I print them and we'll be here to discuss it. Okay. You called this morning when I was setting up the system. I got that, so I tried to communicate with everybody. And please clarify if there is anything that you are missing. Please let me know. I'll be glad to do that. But we need to get the maximum benefit. You send a link 1 hour before. No, I don't do that. No, this is not from me at all. We don't involve at all. Here we don't involve at all. 1 hour or 24 hour, we don't involve in the webinar issue at all. The moment that I reserve the webinar, we send the ID to you, the ID, and that's it. Okay. After that, it is done from their end. Okay. And since you know what time you're supposed to join, you join me at the regular time. And if there is any problem with their system, let me know. I will be glad. But the only thing that it is the ID, and after that, the rest of communication is from the webinar company and you. So as long as you are getting the ID and you are able to join us, this is the most important thing, John. Okay, I wish you the best. No problem. So what is a signal warrant? A signal warrant is basically a requirement set by the MUTCD in order to tell us as a provider so the signal warrant is a set of requirements and these requirements, if these requirements have been met, that means that we have to do something at this specific intersection. Set of requirements, okay, set by MUTCD, okay, to decide if a signal is needed or not. Okay, so you have an intersection here, and the analysis of the MUTCD based on the definition of a minor road and a major road. So they are saying that if we do have a major road intersecting with a minor road, so if this is a major and this is a minor road, and in the problem statement they have to tell us which one is a major and which one is a minor. Okay, you have to define the major and the minor roads for us. So we have volumes on both streets, so volume here and volume here. So they came up with the 9 warrants to tell us for this specific intersection here, if one of these warrants has been met or we meet all the requirements of the warrant, that means that you have to consider installing a signal. This is what is meant by a signal warrant. Is signal needed here or not? If we go over the warrants and one of them is sufficient, one is sufficient to trigger the installation of a signal at this intersection in order to give everybody a fair chance of moving around, to protect the public from accidents, name it. Okay, many okay requirements through these 9 warrants. So this is an overall definition of a warrant. A warrant is okay a set of requirements. If these requirements have been met, because some warrants they have more than one requirement, that means that a signal okay should be considered to install it at this intersection in order to 2 things. A signal, they look at it is a traffic control device. Okay, first of all, a signal is a traffic control device. A traffic control device, like other control devices, we talked about it in the previous chapter. So this is considered a traffic control device in order to control this intersection, to provide mainly 2 things: safety and mobility or operational. Mobility, or much better word, operational, traffic operation. So in order to provide a safe intersection, and this intersection will operate very efficiently, mean that it has high mobility or it has better operational. These are the 2 main objectives from putting a traffic signal. A traffic signal is not always 100% okay, the right decision. Okay, and this is why they said that you have to do an engineering analysis. If you remember, they are saying that you have to do an engineering analysis, okay, in order to decide even if the warrant has been met. If you look to the 9 warrants, if you go back again to my book, specifically on page 425, so 9 warrants, they list them per MUTCD. And these warrants, by the way, if you go back again 5 years ago or 10 years ago, you'll find these warrants are modified and they changed and improved because they discover something, okay, and the previous warrant is not really very accurate, so they keep adding and improving, okay? So if you are given a problem related to warrants, he will give you a scenario or a situation, and after that he will tell you which warrant has been met, warrant number 1 or 2 or 1 and 2 and so on. So we need to consider all these warrants when we analyze any intersection, but obviously or any situation, sorry, not necessarily to be intersection, but for the sake of the exam, as we did the problem together, the NCEES problem, we found that there is an intersection, and this intersection, we analyze it, and I will bring it again in order to go over it one more time if you this problem here, we solve it together. I'll be glad to remind you, this is problem 530 of the NCEES. He gave you an intersection and I can get another copy or another book that is not marked. Let's see if I have one here handy. So based on that, we can look to the requirements and try to apply it. And yeah, here it is. Let me look to this here. This is, it is, so this is an example that given in the NCEES, the Blue Book, problem 530. And basically, he gave you a table that it has the traffic volumes, and he gave you which one is a minor street, which one is a major street, and he asked you to analyze this intersection using the given data. And in this case, we need to decide if the answer is A or B or C or D. Okay, and here specifically he mentioned the warrant number. So in this case, you have to be familiar with the order of these warrants, where warrant number 1 is the 8-hour vehicular volume. Warrant number 2 is a 4-hour vehicular volume. Uh, warrant number 3, peak hour, and 4, pedestrian volume, 5, school crossing, 6, coordinated signal system, and 7, crash experience, roadway work, and finally intersection near a grade crossing. So those are the 9 warrants. And at the bottom here of this table, with this table, okay, per MUTCD 2009, you will find that a traffic control signal should not be installed unless, okay, at least one or more of the following, okay, of the factor described, okay, in this chapter are met, which is a warrant, okay. So basically, if we do not meet any warrant, don't put a signal, because signals, they have some disadvantages. The advantages, as I said, safety and operation, but also we do have issues, okay, with the rear end accidents, because especially nowadays, everybody is texting and everybody is using the cell phone, okay, or not everybody, sorry, some, okay, so they notice that the crashes or the rear end crashes, okay. So a traffic signal, okay, should not be installed unless an engineering study indicates that installing a traffic control signal will improve the safety and operation, here it is, and or operation of the intersection. Okay, so basically safety and operation. So this is what and I encourage you to read all these guidelines. These guidelines, this is the language given by the NCEES. I really encourage you to read it, and I try to provide a very concise summary as much as I can in order to make sure that we covered as much as we can, but in a very concise form. And I went over them one by one to the best of my knowledge. This was the last meeting when the exam was canceled. So I came here and we already covered the 9 warrants. In order to enhance our understanding, I highly recommend you to go to this book, the AMBM book, and this was sent to all of you. And I will go to chapter 6. Also, the problems here are in the same order as the textbook. So chapter 6. And I will, here it is, signal warrant, and solve the problem related to warrant. For the time being, we didn't talk about the highway capacity management, the HCM, because the other half of the chapter is related to HCM, the Highway Capacity Manual 2016, as far as the green time and the effective green time and signal cycle and all these things. So if you solve only the problems, like for example 121, if we look to this problem, and I believe all of you have the book, so let's start with that. Okay, if you solve it, that's good news. If you didn't solve it, give your friends, okay, a chance to read the problem. Okay, An unsignalized intersection is being evaluated for signalization according to MUTCD guideline. The north-south highway has 2 lanes in each direction, and east-west has 1 lane in each direction. So we do have, I try to illustrate this by some kind of a very quick sketch. So he's saying that the north-south highway has 2 lanes in each direction. So I have 2 lanes here. And you can put a north arrow if you want, just to illustrate that we are following the, okay. And the east-west has 1 lane in each direction. So the following data collected during the peak hour are given. The northbound approach volume. So northbound approach. What is an approach? Approach. Okay. So this is the north arrow. So the northbound approach, he's talking about this one here. Okay. So the northbound approach, the volume here is equal to 570 VPH. And the design speed V here, okay, is 40 mph. Okay. So this is the volume, and this is the speed. Let's call it FVOL. The southbound approach, the peak volume. So here, the volume, the peak volume is 530 volume. Okay. This is per hour. And the speed V is given to be 40 mph. Okay. What is the minimum hourly volume on the minor approach in order to satisfy the peak hour warrant for signalization? So here, based on this, I can call this is a major road, and this here, I will call this is a minor road from the problem statement. So here he's talking about the hour, the peak hour. So if we go to the peak hour, which is warrant number 3, and look to what they have for us, and if you remember the discussion, sorry, I'm using the same book that I marked, and I hope that you did the same thing, as write as much as you can and mark as much as you can the way you want. Even I draw some stuff here also to illustrate all these things. Okay, if it is a 4-leg intersection or a 3-leg intersection, try to and the 1 hour approach, they are telling us that a signal warrant will be met. First of all, a little bit of brief discussion about what is meant by the peak hour. So the peak hour warrant, the peak hour signal warrant is intended for use at location where traffic conditions are such that for a minimum of 1 hour of an average day, the minor street traffic suffers undue delay where entering, okay, when entering or crossing the major street. So they are saying that uh, uh, the volume along the major street is so high such that this will be, by the way, at stop sign here. They will have a stop sign here. They have to come to a complete stop. So they have to come to a complete stop here and stop here. And look to that like the problem here, for example, the NCAAS, they already illustrated that. They are telling you there is a stop here and there is a stop here along the minor road, along the minor street. So they have to come to a complete stop here. They have to come to a complete stop here. Okay, but the traffic flow along the major street is flowing freely without any. But in this case, the people are waiting here for how long? Okay, there is no any gap they can cross or turn right or even turn left, sorry, or maybe turning right, whatever the movement they going to choose. If they would like to go through or they turn right, maybe they can squeeze themselves, but there are some dangerous movement here, okay, where we have conflicts between the the traffic as indicated here. So if the 1 hour warrant, this is what is called the peak hour. If the peak hour has been met per MUTCD, as indicated in the MUTCD, that means that we have to consider to put a signal. So the people on the minor street or the passenger or the user on the minor street will have a chance to cross when it's green or turn left or turn right safely without any, okay? And in this case, the traffic along the major has to come to a complete stop. So this is what is meant by traffic warrant. So if the warrant number 3 has been met, this is number 3, which is a peak hour, and they look to that, okay, as I told you over the years, they develop these warrants based on the need. So the warrant number 3, as explained in the MUTCD and explained during the class, maybe there is a shopping center here, or maybe there is a school or business, okay, uh, along the minor street, somewhere a shopping center or mall or school or business, whatever, a traffic generator, okay, facility. And at 3 o'clock, everybody is leaving. That means that the line along the minor street for the users or passengers or will be very long, and they are waiting too long. So they said that, oh, if this condition exists or this situation exists, you have to consider put a signal, because we don't like the people, okay, or the users suffer a lot while the traffic along the major street is traveling freely. And this is what I mean, again, is meant by a traffic warrant. Okay, a traffic warrant. A condition exists per MUTCD, not up to me or up to you, per MUTCD guideline with the FHWA. This is the federal FHWA. If this is met, that means that we are going. So I will go to the 1 hour. If this problem is given to me on the exam, I will go and I circulated some stuff. For example, the word, okay, the and again, the discussion here, it is exactly what I mentioned, that this signal warrant, okay, shall be applied only, okay, in unusual cases such as office complexes, manufacturing plants, industrial complexes, high occupancy vehicles that attract, okay, discharge larger number of vehicles over a short period of time when everybody is leaving. Okay, the need for a traffic control signal shall be considered if an engineering study, always they are using this, by the way, this, you will find this section is using the word engineering study a lot. Okay, find that the criteria in either, here for a traffic warrants, by the way, we need to pay attention. The word and, or, either, both, or the word all. So they are using these words a lot. This and this or this either, okay, or either this, okay, both, all. So we need to pay attention these keywords. It should trigger us to pay attention to what should be met or what should be satisfied. So is it that if either of the following two categories are met, category A has 1, 2, 3. Category B, which I will start with, the plotted point representing the vehicle per hour on the major street, and it's a total of both approaches. And this is why when I'm going to prepare this, the flow chart, like I prepared it for warrant number 1, and as you can see, I added this to this, and I said, okay, this is an approach. Here it is. I put a north arrow, and I believe all of you received that. If you did not receive it, because some of you are joining me for free, I have no problem with that. Invite your neighbor, invite your kids, I have no problem, but don't invite Corona, please. Okay, the only thing that we need to keep it away is we need to not invite coronavirus, please. Okay, we need to invite only, okay, something useful, kids and your neighbor, your relative, everybody. I have no problem with that. And keep always praying. All of us, we should keep praying that this pandemic will be over very soon. So for those of you who are attending, okay, please, I will be glad to scan this and send it with my notes, okay, for those of you who are attending today, because I have your email, because in order to join, as I said, that you enter the ID and the email, and that's it. And if the computer send you a reminder, 24-hour reminder, that's good. 1 hour reminder, that's good. If not, just join me on the regular schedule or on the schedule as we send it to you. So this is called approach. The code is calling this direction is called approach, either along the major or the minor. Okay, in this direction here, we call it another approach. So this is a westbound, and this is the eastbound approach. So we need to understand. So this is a westbound, and this is the eastbound approach. When we look to the major street, the MU to CD is telling us this is a major. We have to add the two volumes. The two volumes. So this is why I said the volume of two approaches. So we add these two volumes together. That's why I made this here. So whatever the volume given to you on the, sorry, what did I say? I reverse it. I'm sorry. I did something, okay, wrong. So let me correct my mistake because I just saw it. Let me make sure that I am not reversing. So this is the north, so this is the south, and this is east, so this is the east. Sorry for that. And this is the westbound. Okay, just to make sure that we know the four directions: east, south, and west and east. Okay, just okay. So this is the north arrow, this is the south, and this is the east, and this is the west. Just okay. So this is eastbound and this westbound. Sorry, I reverse them. Okay. So the both approaches, okay. This direction here is the one approach, okay, and also the code called this is approach, and so on. So if we look to the problem that's given and we try to solve it, he gave us the volumes. So this is the south bound and the northbound. The northbound is 470, which is this based on this here. So this is a northbound approach, and this is a southbound approach, and the volumes are given, and the speed are given. Okay, immediately, since this is only one warrant, I will go to the warrant number 3 and try to read it. And he said that the plotted point so and so per hour on the major, both approaches, and the corresponding vehicle, okay, one direction only, 1 hour, and the 1 hour is defined any 4 consecutive 15 minutes of an average day fall above. The word above is very important. The applicable curve in figure 4.3c. So where are these figures? These are the figures. Again, you are very welcome to use the original document, and I believe I asked you to buy MUTCD 2009. Is not very expensive book. Try to get it, and you will find that this is the figure for C3 and another figure for C4 at the bottom. One is called the basic one, and one is called the 70% factor. And I said that the basic, we use it, and we do have 3 scenarios based on the number of lanes. And I call this is a basic, and the x-axis is the volume along the major street total of both approaches, vehicles per hour, VPH, and the minor, we pick the higher volume for one approach only, and we will decide if we are going to use this curve or this curve or this curve based on the number of lanes. And the points must fall above. As you can see, I put it here during the discussion. The points must fall up above. On the same page, there is another figure they call a 70% factor. And the 70% factor will be used if the V major exceeding 40 miles per hour. Okay? Or the population is less than 10,000. Either this or this. If you have in the problem statement some indication that the volume it's 10,000 or the V is given, that means that this is a 70% factor curve will be used immediately. Immediately, I will think, okay, like the problem, the NCEES, he give us the 85th percentile, problem 530, 45 miles per hour. So this is an indication that the V major, okay, V major is exceeding certain limit, and the population is giving us the 12,000. That means that the population hit a certain limit. So these two here will trigger something to me for the warrant number 1 or rest of the warrants, whatever the warrant is. Okay. So based on this given problem in my book, the AMBM book, let us do it. Let me give you 1 minute so you have all the tools. And in this case, you can tell me. And the east-west bound design approach is 35 miles per hour. So the V here along the minor is 35 mph. So let me give you a couple minutes to do it, and let us see if you are coming up with something to match one of these four answers. If this is the case, that's good news. And if it's not, yes, Ray, thank you. I correct the eastbound and westbound. Okay, so and try to do your best as far as the four possible answers. So the northbound approach, I have 570, and the southbound approach is 530. So these both approaches here, the volume, if you add them together, because we add the volume on both approaches for the major street, and you will find that the total is the 570 and 530, 1100, I believe. That's correct, 1100. And since the V, by the way, the V, the 70% factor, here we are talking about the V major, not the V minor. Be careful. The V major, okay, is not the V minor. He gave you just the V minor, okay. So I will come here, and here I have 2, 1. I have 2 lanes in each direction for the major street, and 1. So I will go 2, 2 and 1. And obviously, I'm not going to use the 70 because V major, it must be greater than 40. He gave you exactly 40. It's not equal. It must be greater than. Okay, be careful. Okay, and I wrote this more than once, and I try to write everything as much as I can. So be careful with greater than, or equal, all these things. So obviously, I will use this figure, which is the mean figure or the basic. Okay, the basic. So I will, along the x-axis, I will go with the 1100. This is the way we do it. The total volume or both approaches. And I need to decide I am 2 and 2, or 2 and 1, or 1 and 1. Obviously, I am the blue one. So I will go up and just barely above the line. And I will move from the just the line above, or the point above, and I will move this is the way we do it, and try to read it to the best of your engineering judgment. this is 200, and this is a 300. So I am above the 200 and I am below the 300. So I am here, I have 180, I have a 320. I doubt that will give you the volume to the nearest, okay? So in this case, my best answer is going to be 250, which is the answer B as in boy. Okay, so, and I hope that the four answers are given, okay, such that there is no any uh, um, um, two answers are so close to each other such that you are telling me, oh, I am just barely above the line and I hit this. 320 is somewhere here, 320 is here, and 185 is here. So the 185, 180, sorry, 180 and the 320, obviously. Okay, so this is an example of uh, the traffic warrant. Okay, this is very simple one because it's only one warrant and we applied, and I hope that everybody got the same answer. If not, please let me know. And again, I did all my best with all my books. If you find a typo or a mistake or an error, please email me and I will do my best to review it. And if there is anything, typo or mistake or an error, okay. Okay, so this is uh, the warrant um, uh, for a typical problem. Not necessarily. Some problems are really lengthy. Okay, and um, um, and some problems, by the way. Um, let me just add one more thing, because this is also I do have it in one of my mini exams. Uh, every little tiny thing that given in the MUTCD or any other book, very important. It says here, I'm reading also from my book, and I apologize that my book is messy, but um, um, he is saying here at the bottom, which I picked this from also from the MUTCD. I am in my book for page 428, page 428. It says here, if this warrant is the only warrant met and a traffic control signal is satisfied by an engineering study, the traffic control signal should be a traffic actuated. A traffic actuated or actuated. Okay. The traffic signals. So again, let me repeat again, because they might tell you which of the following is true about which of the, I believe the question I have, if I'm not mistaken, which of the following, somewhere in my book or in my mini exams, whatever it is, which of the following is true regarding a traffic warrant 3, traffic warrant 3. And he will give you 4 answers, A, B, C, D. Okay. And one of them is related to this, that the traffic signal, it should be a traffic, they will give you something, a traffic actuated, or ACTU actuated. A traffic actuated signal, at the beginning of this chapter, there is a table. We did not cover it yet, but just I need to bring it. At the beginning of my book, a summary of the type of a traffic signal controller. Table 2. One is called permitted. One is called semi-actuated, and the other one is fully actuated. This is on page, by the way, page 399. 399. Permitted, by definition, and this is from the textbooks I have and I used before, permitted a signal whose timing, which is a cycle length, green time, and so on, is fixed over a specific period or time periods and does not change in response to the change of the traffic flow at the intersection. So in this case, no vehicle detection is necessarily within this mode of operation. So it is the signal cycle has been set, and the traffic volume in either direction has nothing to do with the signal operation. This is called permitted. The other one is called semi, actuated, which is the second one. That a signal whose timing, again, all the parameters of the signal, is affected when a vehicle are detected either by video or by pavement, some kind of loops. They put loop detectors or camera. Some probably both of you or both of these probably you saw them or you on some but not all approaches. This mode of operation is usually found where low volume road intersects a high volume road, often referred as the minor and the major street. This is called semi-actuated. Okay, the other one, which is fully actuated, it is a signal whose timing is completely influenced by the traffic volume when detected on all of the approaches. Fully actuated signals are most commonly used at intersections of two major streets where substantial variation exists. So I need to know that. Okay, so here for a traffic signal warrant number 3, they are telling me there is a minor street and a major street. And this is a 1 hour warrant. 1 hour warrant. So the signal, if after engineering analysis is completely done, after we meet this warrant or after this warrant has been met, he said that in this case we need to consider the traffic actuated one. In this case, probably the loops or the cameras will be placed here because after the business or after the school or after the shopping center, everybody went to the shopping center, at the end of the day to buy groceries before they go home. So there is a lot of traffic. But after this peak, the traffic along the minor street start to decrease. So why should I penalize the people here along the major street for something does not exist here? So in this case, the loops or the cameras will be okay in this case. And this is what they mentioned, that if this is the only, be careful by the wording, by the way, the word only. If this is the only, if warrant number 3 is the only, here it is, the word only, I circle it, because as I told you, if this is the only warrant, and probably in the question itself, it says that, which of the following is true, is true regarding traffic warrant number 3. If he stopped that means that he's talking about only a traffic warrant number 3. I will say that not necessarily word only will be injected in the question itself, but if he say traffic, which one of the following is true? So one of the answer that if, the traffic signal should be traffic actuated, and in this case probably they can be more specific and it is fully actuated, or the semi, it will be semi. In this case is not fully actuated because these are the one major, and even he might ask you, he might even complicate the things by inserting two words, sorry, where it is, and probably that's a good question. It will be fully I will say fully traffic actuated, or the other answer, it will be semi, okay, actuated, traffic actuated. He will consider both of them. Obviously, it will be, okay, semi-actuated because it's not fully. Fully, we apply it only, okay, when we have the two streets are considered our major streets. Okay, when we have fully actuated, that means that we have actuated at the common intersection of two major streets. Do you see the word two major streets? Circle that. Okay, we have two streets, but the variation of the volume, okay, in one street with respect to another varies, okay, from time to time. And this is by traffic count. They do traffic count and they see, okay, we have two major streets are intersecting. This major street is in the afternoon is traffic volume so and so. In the morning, the traffic volume is so and so. So in this case, they can do the programming such that it will not penalize street against another street. Let me do this very quick. So if it is two major streets, okay. So in this case, and I am sure that when you start to study and do all these problems, you will come with tons of questions. I have no problem with that. And this is what I intend from this summer uh, workshops, okay, in order to keep your brain fully actuated. I need your brain to be fully actuated always, okay, not semi, okay. I need your brain always fully actuated, okay, so it's always working. So this is a major street, in this case a major and a major street. So in this case, okay, in the analysis maybe, or say how we define major versus minor for the analysis for the signal, maybe the traffic volumes in this case will be the volume, the street that has lesser volume, I will consider as a minor street, and I will do the analysis based on that. I don't expect that for the sake of the exam, and this is why, by the way, if you look to warrant number 3, you will find one curve is 2 and 2, okay? If you look to warrant number 3, you have 2 and 2. So you could have 2 on the major and 2 on the minor, okay? So the first number is for the major, by the way. This here is for the major, and the second number is for the minor, okay? So we have 2, 2, 2, 1, and 1, 1. This color and this blue and this color, the pink, and okay. So I needed to be aware of that, such in case. So in this case, if you have two major street intersecting, okay, and this intersection has signalization, so in this case it must be fully traffic actuated scenario in order to make the operation easy for everybody. Nobody will be suffering, okay, excessive delay, as we mentioned at the beginning of the discussion. Make sense? Okay, good, good. All these things are very useful, and I hope that all of you, the rest of the problems, for example, conceptual questions, question, since already I sent the flow chart to you, question number 126. 126. What do you think? Okay, warrant number 1, which is the 8-hour vehicle, is satisfied if only 100% condition A is satisfied, only 100% condition B is satisfied, or 80% condition A and 80% condition B is satisfied, and the word "and" is very important, or all of the above. Again, I will go to the summary I provided, and again, as I always say, try to do your best. Okay, so if you go to the summary, which is a last summary I've provided here, I hope this is summary. This is the overall summary or overall view of the warrant number 8. Not warrant number 1, 8 hours. Okay, the 8-hour vehicular volume. So if I have 100% A or B, if any of them is met, that means that I am fine. So I would say that only if satisfied, yes. If it is only 100% for condition B, yes, because I have the word or here, not and. But if you look to the 80%, 80% of the condition A and is satisfied, and here it is. So the word and is here. In order to meet the warrant, if I'm going to use the 80%, because if I met the 80%, and I will tell you that now, okay? So in this case, you have to satisfy the 80% of condition A and 80% of the condition B. Make sense? So do you agree that the answer is D as in David or doctor? And as I told you that I provided answers and I did my best. I hired somebody to review it for me, but I reviewed extensively at the end. But I am human being. I do mistakes like anybody else. So if you find a typo or a mistake or an error, please let me know. So we need also is not just a matter of calculations that we did, also conceptual questions. And sometimes the conceptual questions, by the way, are a little bit tricky or tricky. Let me put it, is not a little bit. Most of them are tricky, and we need to be paying attention. And as I said that, I start working on the other warrants to put it in a flow chart like this because I found that engineers, they like flow charts, drawings, illustrations, tables, all these things. I did it. Hopefully that this made your life easy. Step number 1, step number 2. I did all my best. I prepared it and I gave it to somebody, and I will finish all the 9 warrants this way, and I will be glad to send it to all of you, even for those of you who are attending, okay, for free. Okay, so let's take a few minutes to break, get some fresh air, clean from any viruses, please. Get just only fresh air, please. Okay, we need only fresh air nowadays without any viruses. It doesn't matter what type of virus, corona or any other viruses. Let's do our best, and we'll keep praying, and hopefully that everybody will get out of this crisis safe, family, or the whole world. We pray for the whole world. Okay, thank you. Let's meet after 10 minutes from now. So it is 10:16. So it is 10:26, please, or 27. Thank you. Okay, welcome back everybody after this short break. I hope that you got some fresh air from outside, which is good news. Okay, but the problems in the chapter. Okay, everything it is per chapter. If you have this book, either from the previous semester or current semester, but I believe we send it to all of you. It is the problem. You should know the order of the book. Okay, which I mentioned, or let me remind you if I did not mention it. Could be my fault. Have no problem with that. This book is divided into two sections, and I hope that you already mark it. Before the part one, which is the AM topics, if you are talking about this book, okay, which is the AM and BM, Brack's problems and solutions in the transportation. So part one is the AM, which all these problems here for the AM, 127 problem, I believe, or no, sorry, 30 problems. 127 in the other book. Okay, so and part two, which is the transportation depth, it goes with chapters, chapter 1 to chapter 10. Even I put at the beginning of the problems, I put the 10 chapters one more time because I needed to be aware of that. These topics here: chapter 1, chapter 2, chapter 3, chapter 4, and chapter 5, all the way until chapter 10. And after that, I took each chapter and I did my best to generate problems. And here it is, chapter 1, with all listed topics and the percentage. And I have all these problems all the way until chapter 10, which is the last chapter. And this is 170. So this is chapter 10 of the problems. And it says at the bottom here, I put the index here at the bottom, the transportation depth Brack's problems. So this is chapter 10. Okay, problem starting with problem 171, 172, 173. So I have 173 problems here for the PM and 30 problems for the AM. And this is why we are saying that more than 200 problems is 203 problems. After that, the solutions are provided. Also provided by the same order, the breadth, and after that, the depth. And I hope this is what it is, transportation depth solutions, problem number 1, all the way to problem, also this, okay, problem number 173, the solutions. So please let me know if you have something different, or probably your book is not complete, or probably we send you the wrong book. I will be glad to correct that, my friend, okay, no problem. So this is the AMBM book. It goes with the same order as the textbook itself, okay? I hope that this is the answer you are looking for, my friend, okay? If you are missing a book, send an email to me, okay? Because I will forget, and I will do all my best. My staff they are not in the office right now, but I would be glad to send even my copy right now to you if you are short. And after that, I will produce a copy for myself later on. The practice exam I sent, or the mini exam I sent to you. Let me just find the cursor here. At least I can. Okay, the actuation. This is in the textbook itself. The chapter I was showing you, it is in the textbook. Okay. Sorry if I didn't mention the page number, but I wrote the page number 399, if I'm not mistaken. This in the textbook, the Transportation Module Reference Manual. In the textbook at the beginning of chapter 6, which is the signal design. Okay. If you flip the page, you will find the table over there on page 399. Okay, this is what I was talking about the difference between DC traffic signal controllers. Okay, make sense? Okay, I hope that you got it, my friend. The mini exam I sent to you, I hope that all of you got a chance to work it out, and I still believe that try to do your best, and I will do my best, okay, to provide you with more problems. For example, if you look to this problem here, problem number 9, um, questions are not straightforward. So even if you don't have the practice exam with you, or the mini exam, sorry, mini exam number 1, the one I sent it to you way back, you are very welcome to read it from here. And I will give you a couple minutes to read it and tell me what do you think. Okay, so it is required to join two highway center line tangents with a circular curve of radius 1,000. So this is the center here for the circle or for the curve. And we have the beginning of the curve and the end of the curve. This is also, we call it PC, point of curvature. And also we call this is PT, point of tangency. The PI is inaccessible. Okay, maybe we need to draw some kind of a lake like that, probably. Okay, so the PI, it is located in a lake, is not accessible. We should draw something like that. Falls in a lake to show you. So this is the PI, the point of intersection. So points A and B are established near the lake. So point A and point B are established near the lake, as shown on the back and forward tangent. As you know, this here, we call it back tangent. Always back tangent is associated with the beginning of the curve or the point of curvature. And this is a forward tangent, as you know, forward tangent. And the forward tangent always associated with the end of the curve or the point of tangency, PT or EC. So he located 2 points, and he was able to measure the distance between A and B, which is given to be 615.27, and the angle alpha and the angle beta also were determined and given to you as these two angles. And the EC station is given. This station here is given to be 18 plus 0, 0. The end of the curve station or the point of tangency. He's asking for the PI station. Okay, as you know, from here to here, this is a tangent t, and from here to here also a tangent t, and they are equal. These two tangents must be equal. So if you calculate the tangent t, which is given by this equation r tan delta over 2, if I remember the equation correctly, and you subtract the t distance from this station to get the pi, you are doing something wrong. Because if you remember, I said that even the pi is physically at a distance t from the end of the curve, but the way it works, if I know the pi station, minus t will give you the bc station, you need to add L to it. Even if the difference is small, but still, this is the right way of doing it. So we're saying that the BI station or station of the PI, whatever the station of the PI, the point of intersection, minus T, this will give you the station of the BC. And if you add L plus L to the BC station, this will give you the station of the end of the curve, slash BT. This is the order. This is the order of computing the stations. I come from here to here. Yes, I can do that. Add L, yes. So the moment that you read the problem, you have to, okay, get the proper equation and use them correctly and use the correct steps. So by reading this, it seems to me that I need L and I need T in order to solve this problem. And we said T is equal R10 delta over 2. I know the radius is given. Do I know delta? Delta is the deflection angle or the central angle. This is delta, by the way. And this also, this angle from here to here is also delta, which is a deflection angle, or this is the deflection angle between two tangents, which is the back tangent and the forward tangent. It's called deflection angle. Here it is. This is a delta between these two. Okay, because as you know, the angles or angles in general, they are either exterior angles, exterior angles, or interior angles, or deflection angles. Those are the most important three types of angles that I needed to remember them. Oops, I'm sorry. Sorry, I pushed something. Okay, the cable. I will get it back. The camera, I believe. I will get it back very soon. Sorry, I pushed something here. I moved one of my books, and let me see if can I. Okay, I'm getting back. Okay, sorry for that. Or this technical difficulty or that. So the deflection angles are the going back to the problem. Thank you for the answer you provided. Okay. So the deflection angle is delta. So the deflection angle is an angle between two lines or two tangents, AB and BC, the famous. I said there is a deflection angle between AB and BC by extending this line, and this is a deflection angle to the right. Because deflection angles either to be to the right or to the left, as you know. To right or to left. We need to be aware of that. And the sum of the deflection angles, by the way, sum of the deflection angles for any closed polygon is equal to 360 degrees. Okay? And they agreed that the right angle is positive and the left angle is negative. So if you have any closed shape, oh my God, I didn't do anything other than just I moved the move all the cables away. It seems that all these cables are causing damage for me. So the sum of the deflection angles and when we sum the deflection angles right or left, as I told you that they assign a positive sign for the right deflection angles and negative for the left. So for any closed polygon like that or a closed shape, it doesn't matter how many sides. If you add all the deflection angles for this polygon, it should add up to 360. The interior angles for any closed shape, these are the interior angles. It is n minus 2 times 180 degrees. The sum of the interior angles were in the number of sides. The exterior angles, these angles here, it is the sum is equal n plus 2 times 180 degrees. And I'm sure that you remember all these things. Okay, but just a reminder. Okay, so here we have this deflection angle. This deflection angle here, it does equal a alpha plus beta. Delta, the key here, delta is equal alpha plus beta. And we know that because an exterior angle for any triangle, this is, assuming this is delta. So delta is equal alpha plus beta because we know that delta plus gamma is equal 180 degrees, straight angle. But I know alpha plus beta plus gamma is equal 180 also. So if I take this out, so we concluded that delta is equal alpha plus beta. And we remember this from a trig in high school. The external angle for a triangle is equal the sum of the two internal angles except the one next to it. So this except, so delta So this is a whole problem here, that if you add these two angles here, this will give you delta. So if you add 51 degree and 31 minute and 20 second to 32 degree and 02 minute and 45 seconds, if you add them, you will get the angle delta. And I don't know, I received the calculators, but I never send it to you. They are sitting here, believe me, since I received them. And we need to make sure, this is a calculator that maybe all of you have it, or most of you, but, and I said that I'll be glad to send it, okay, to you for free. Okay, this is one of the calculators available in the market, which is FX115 ES plus Casio. If you prefer HB, if you prefer um, 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 uh, other brand, Casio, HB, um, uh, Texas Instrument TI, whatever calculator, but as long as you are getting these things easily and quickly by push a button, all the calculators, they have this. They convert degrees, minutes, seconds, and vice versa. You have to do this very, very quick. Well, don't take this divide by 60 and add it to here, divide by 60, add it here. No, you're supposed to enter this one shot, push a button, you will get it in degrees. And after that, you can add this and you'll get the angle, okay, delta. Okay, after getting the delta, in this case, I can solve for t. T is equal R10 delta over 2, the equation I wrote before. Okay, if you do that, you will get delta. By the way, I got it here if you add it. Okay, so it is 83.57 degrees. Okay, and if you put the R 1000 and get here, so you'll get a T of about 893.60 feet, and correct me if I'm wrong. And L, which is the length of the curve, we have more than one equation, which is 2 pi R, okay, one of the equations, delta over 360, okay. And I always remember this equation, that this came from a circle, okay, and as you know, if this is the radius R, so a circumference is 2 pi R. But if I took only a portion of this circle and make it as an arc, so I am proportioning delta with respect to 360, because the circumference will occur when I have 360. So I always remember this equation. L is equal to 2 pi R, which is the circumference of a circle, and I proportion the central angle with 360, because L is happening when I have 2 pi R, it's happening when I have 360. So if delta is equal to 360 over 360 will give you 2 pi R, which is the full circumference. Make sense? So after doing the L calculation, because there are three equations for the L, I got an L of 1,000 with the rounding. So in this case, I have the two pieces of information I need. So in this case, since I know that the L and I know this station here, so 18 minus L will put me here. A plus T will put me here. So the PI station, the one I'm looking for, is equal to 18 plus 00 minus L, which is 14 plus 58.60, a plus T, which is the T is given to be 893. If my math is correct, so it is 8 plus 93.60. So I hope that we are getting something. Let me make sure that the T is correct. So 83.57 Math is not big deal. 0.5 times is important, but 10 and 1,000 times, yeah, 893.60, that's correct. So in this case, if I take station 18 and 14.5860 minus 8.9360 plus, I got about 10 plus 35.00. Sorry, 12. I copied it wrong. Here it is. 12, okay. 12 plus 3500. So this is the closest answer. 12 plus 36, maybe the rounding here. So probably the correct answer, the closest one, maybe I can correct that. It depends how many decimal places did you carry, but this is the closest answer. That if you subtract t, if you take 18 and you subtract t from it, just for the sake of discussion, if you take 18 plus 00 minus t, so it is t is equal 8.93, so 18.00, enter. 8.9360 minus will give you, okay, something, okay. So if you take this station here, 18, and you subtract t, which is 893, okay, so this will give you 9 plus 06.40, which is this here, which is the number here. And this is the answer A, by the way. This is the answer A, which is completely, totally wrong. Okay, this is the answer A. He gave you the answer A to mislead you. Okay, by subtracting t from this station here to bring this station here. Yeah, physically, yes, t is a distance between the pi and the t and the end of the curve. But when we drive this way. Okay, we don't drive, go this way and come this way. Okay, so this is the right way of doing it, and be careful because the wrong answer, okay, they give it to us in order to distract us, and we'll go home happy and saying, oh, I got all the answers. Yes, you are right. You found all the numbers over there, but these numbers are totally wrong. Okay, I hope that everybody got the same concept and the same understanding of this problem. Okay, so I need you to be aware of that. Okay, thank you very much. The second problem that some of you asked me about it, this problem here, problem number 11. And let me keep this window away from it. At least you can read it. For those of you who do not have the number 11, please. And we need to understand what they are looking for. It's saying that, let me give you a minute, or let me zoom in. At least you can read it. And hopefully the camera will not disappoint me. Here it is in front of you, just in case if you did not have this handy with you right now. Okay, problem number 11 of the mini exam number 1. The distance from the center line to a tree probably this is supposed to be of a tree to the pi. Okay, here we go. Of a tree to the pi of a circular curve is given to be 32 feet, which is from the center of the tree, to see from the center or from the edge. The new highway width is 50 feet, will be constructed. Okay, the minimum horizontal clearance required from the center of the tree to the edge of the pavement was determined to be 8 feet. The deflection angle is given. What is the minimum central radius of the new highway curve? So the radius is the one is missing, and I would say this is the beginning of the curve here. This is the end of the curve, or this is a PT. Doesn't matter if it's curve to the right or curve to the left, but in this case, this is delta or I, which if I extend this is also delta or I. Some books, they call it I, majority of them. So we do have a road that it is 50 feet wide. So the cross section of the road, if this is the center line, I don't know the lane width and I don't know the shoulder width, but normally the lane width is 12 feet. And the new highway width is 50. This is the entire width of the road bed. We call it the road bed. Is equal 50 feet. So 25 and 25. So maybe whatever the shoulder width will be, we need to be 8 feet from the edge of pavement. So I will assume that from here to here is 25 feet. Okay. And I need 8 feet horizontal clearance to the trunk of the tree, or to the center of the tree, the center of the trunk of the tree. To the edge of the pavement. So what do you think? Which equation we need to use? So I know from here to here is 32 feet. And as you know, for a horizontal circular curve, we have two distances. One is called M and one is called E. M is the middle ordinate and E is external distance, as you know. So let me draw something. So if this is the horizontal circular curve, and we have the beginning and the end of the curve, so this is the back tangent, and this is the forward tangent. and this is the pi, and this is the delta, and this is also delta. And we have this is normally this is a center line, by the way. This is the beginning of the curve, and this is the end of the curve. So he said that there is a tree here, and from here to here is 32 feet. But I need additional 8 feet here in order to get to the edge of pavement. And I know the width of the road from here to here is 25 feet. Because the road is 50 feet wide, whatever the number of lanes and the shoulder, and that's not the point. So 25. So the width of the road bed is 50 feet. So I took the center line to be in the middle, 25 feet. So this is the edge of pavement. This is EB, edge of pavement. So we call, as you know, the distance from the PI all the way from here to the center line. We call this is E, which is external distance. So the E in this case is equal what? Is equal 32 feet, which is given, a plus 8 feet, a plus 25 feet. Agree with me or disagree? If we agree, we can proceed. If you disagree, don't take me to court. We can resolve our differences here. So this is 40, 40 plus 25 is 65 feet. If I translate the problem into English, which is I told you, always draw some kind of illustration or a graph or free body diagram, whatever you like to call it. So in this case, the problem became so easy. I know the external distance, E, we have equations. Some of them you can memorize, some of them you need to derive, some of them you just open the book and read it without reading. We have more than one equation, like for example, R divided by the cosine delta over 2 minus 1. This is one equation. I can show it to you. Or R tan delta over 2 tan delta over 4. Or any other equation that you derive or you have it, access to it. And they have all these problems. Delta is known and the E is known. The only unknown here is R. If you solve for R, I hope that you get about 5179.60 feet. So 5179. I don't know which answer did I select. 5179. So the answer is B as in boy. Okay. So the problems that you might see on the exam, they are not very straightforward. They have some kind of tricks or some kind of. But if you understand the concept, I believe you will be able to handle this very well. And as I said that, so okay, this is a problem. Let's go to a problem for a vertical curve. For example, problem number 16. Let me give you a chance to read it. Okay, a 640 crest vertical curve has entering grade 4%, so it is a plus 4%, which is G1. We call it entering grade, by the way, G1. We call it entering grade. And the other grade is negative 4%, which is G2, or as uppercase or lowercase, as you know, or we call it exiting grade. And this is a vertex here. And we have a vertical curve connecting these two grades. And this vertical curve length, L, to be 600 feet. So this is the beginning of the vertical curve, and this is the end of the vertical curve, as you know. Or we call it vertical point of curvature or vertical point of tangency. So naming also, we need to be familiar with all other names just in case. For some construction constraints, it is required to retain the same grade rates. We are going to keep G1 and G2 the same, and to lower the elevation at the center of the curve by 2.5 feet. This, by the way, the center of the curve is here. This is L over 2, and this is L over 2. How I know that? Because as I told you that vertical curves, they are either symmetrical or unsymmetrical. Or unsymmetrical, or asymmetrical as we call it. Unsymmetrical or asymmetrical. Symmetrical vertical curves, those are the vertical curves where the vertex V at L over 2. It has nothing to do with G1 and G2. Just a coincidence that the G1 and G2 are equal magnitude and opposite sign, just a coincidence, but is not required for a symmetrical vertical curve to have the G1 and G2 to be equal. No, with opposite signs, no. Unsymmetrical vertical curves or asymmetrical vertical curves, V not at L over 2. The vertex will be shifted to the right or to the left. So this vertex here for symmetrical vertical curve must be at L over 2 from each end. Make sense? So I need you to be aware of that. So I said that we need to lower the vertical curve by additional 2.5 feet. Okay. I need to bring it down for whatever constraints. So I need to come up with a new length. So in this case, I'm going to lower the vertical curve. Let me draw another vertical curve with different color. Hopefully I can. Here it is. So I need to lower. So I went down here by a distance of 2.5 feet. I bring this point from here to here. So the original curve length was 600. Obviously, the new curve length will be more than 600, which is from here to here now. So this is a new L, the one I'm looking for. And he gave you all the answers, by the way, more than 600 for sure, to confuse you, because if there is any answer 600 or less, I will exclude it by the process of elimination. But again, in my book, you will find that, or my books in general, you will find that the vertical curves either sag or crest. It does not make any difference if it's a crest vertical curve as the one given in the problem statement. Excuse me. This is a vertical curve where the vertical curve is parabolic curve, is not a circular curve, so it does not have a radius. So parabolic vertical curves, they follow this equation. Y is equal ax squared plus bx plus c. This is the general equation for a parabola. But in surveying, we say that y at any distance x is equal the y of the beginning of the vertical curve plus g1x plus rx squared divided by 2. Rx squared divided by 2. And this is the beginning of the vertical curve, and this is the end of the vertical curve. Or we can say this is a vertical point of curvature, and this is a vertical point of tangency. Sorry, this phone is noising, but anyhow, let me turn it off. If you look to these three terms, by the way, this is the elevation here with respect to a datum, whatever the datum is. So this is, if this is the datum that we are using to reference the elevation, so this is the y of the beginning of the vertical curve, y of the beginning of the vertical curve. This is the first term. The second term, g1x, this is g1, and x, as I mentioned, measured from here. All the distances are measured with respect to this point. This is my reference point. If you remember, I use the word reference point many times during the class because sometimes they give you a distance from the end of the curve. But this, I need you to remember, this is the reference point. Reference. All distance x's, uppercase or lowercase, are measured with respect to the beginning. So G1x will put you here, somewhere, whatever, it depends on the x. Rx squared divided by 2, which is the third term, because I have three terms for this equation. Rx squared divided by 2 will bring you down, because R For this one here, R for this curve, by the way, this is a crest vertical curve, R is negative because R is equal to G2 minus G1 divided by L. And this is the G2. G1 is positive and G2 is negative, like in our case, negative 4. Negative, positive 4 will give you negative 8. So R is always negative for this type of vertical curve, for the crest vertical curve. It doesn't matter which type. If you remember, we talked about types, Ashto, and so on. So the R is always negative. This is why when you add the third term, Rx squared divided by 2 will bring you from here down, because this equation will give you the elevation along the curve. So the three terms, the elevation of the beginning, G1x will put you here, x squared, Rx squared, which is this term here. This is Rx squared divided by 2. I need you to understand this concept very well. Because if you look at this distance from here to here, this we'll call it, by the way, E. I call it in my book also sometimes D sub O. But the Ashto, they call it E, like external distance for a vertical, for a circular curve. But I have no problem with that. So E, from here to here, I can say that E or D sub O is equal Rx squared divided by 2. But what is the value of X here? The value of X is equal L over 2. From here to here is L over 2, as you know. Because we said this is a symmetrical vertical curve. So if you plug here the R and the X, L over 2 will give you L squared over 2. And I have another 2, which is 2 squared, which is, let me spell it out, 2 times 2 squared. So this will give you R L squared divided by 8. But R is equal G2 minus G1 over L. L can cancel with L, so this equation, it can be simplified like this. G2 minus G1 times L divided by 8. And you'll find this equation in my book, by the way. Are you following me? So this distance here is, and this is the key to the problem. If you are able, I'm telling you this story because just in case, if you are not able to find the equation, sometimes that while you are studying, you can understand the logic behind the equation or the concept of the equation. So this, and you will find this equation exactly given in my book. Again, locating the equations, which page, try to mark your book, try to put labels, try to put tabs. This is a success, or the key to success for the exam is to locating equations quickly. You don't have to derive equation like this on the exam, but I'm saying just in case you know what is the logic or what is the concept of the problem. What are these two terms? And I explained this in the class, if I remember correctly. So if I'm calculating this first, and after that, I will add another 2.5 feet to it, because this is what they told me in the problem statement. I can bring this down, additional 2.5 feet. So this is a new E. And I know everything except L. That's it. Are you following me? So let us do this. And I hope everybody is following me. And if not following me, please let me know. Don't think about the stock market. What will happen to the stock market tomorrow? Is it going to go up or down? What will happen to the Zoom stock? Is it going to go up or down? It went up almost 50%, by the way, Zoom. I don't know, did you buy it or not? Okay, so So right now I will calculate E original. Okay. The E original based on the 600 E or D sub O, as I told you, it is G2 minus G1 divided by 8 times L. So I can say that it is G2 is negative 4, negative positive 4 divided by 8 times 6. Here you will find that I put two vertical lines because we take the absolute value because the distance can be negative, cannot be negative. So in this case, it is 8 over 8 times 6. That means that the original E is 6 feet. The new E or in new D sub O is equal the original 6 feet that I just calculated, plus how much they asked me to lower the vertical curve by, which is 2.5 feet. So in this case, I will lower this by additional 2.5 feet. So this is the new. So I say that 8.5 feet is equal to the same equation I'm repeating, okay, which is G2 minus G1 divided by 8 times L. So the L is equal to 8.5 times 8 divided by G2 minus G1, which is 8, cancel out. So 8.5 stations. Since I dropped the percentage, I ended with the stations, or 850 feet. And this will be my answer. And I hope that we have 850. Bingo, here it is, the answer B as in boy. Makes sense. Again, following this logic. Sorry, I'm taking too much time to explain things. Okay, but of course, the purpose, as I told you, that is to help you to understand the concept as much as I can. And after that, it will be a piece of cake later on. So what I encourage all of you is to go over this mini exam. If you didn't solve it, please solve it as much as you can. Some of them already will solve it in the class as far as I know, and some of them are easy, and some of them are tricky, and some of them are lengthy, and some of them you need to search. Try to understand the concept and try to do your best, okay? And I will do all my best to keep working with you guys. So the mini exam number 2, hopefully I can get it to you very soon. I'm working on it. Which I will go with the same order of the mini exams as far as the material. So for example, this year related to the first portion of the course, and after that I will jump on the second portion and so on. So I will do all my best to keep working as hard as I can. Just pray for me to stay healthy, and I will pray for you to stay healthy, okay? And the postpone the exam. I hope that this will give you extra time to do it. So I hope that next exam, which will be October, according to the schedule here, is supposed to be October 23rd, 2020. I hope by that time this coronavirus is over, and I need it to be, okay, this is the last national exam the NCAAC are going to take, and I wish you the best. I have to stop here because I have to go somewhere. I have a family commitment, okay, to do something, okay, so I told my wife, because she's complaining that I'm teaching during this period. I'm supposed to be off. I told that's fine. But so I will stop half an hour short today because I have to go and do something. Okay, commitment. So forgive me for that. Stay healthy and pray for me, and um, uh, uh, come to the proper class. Construction group, they will have their share also of this free. So on 4/4, April the 4th, okay, I will be here from 1 to 4. I don't know why from 1 to 4, unless I have something on Sunday morning, Saturday morning. I have something, I can remember. Maybe the same class I have it here. Yeah, I have you guys. I have the AM. Oh, I have AM in the morning and I have construction in the afternoon. That's why. Okay. But only one ID, as I mentioned, I made it so easy for you, so you don't have to enter ID or ask where is the notification from from this and this. It is just only one ID. Enter it once, and after that, you will be able to attend all the classes, but to come to the class of your interest. If you are construction, come to the construction. If transportation, come transportation. But you are very welcome to attend. Uh, I see some names today from seismic and surveying classes. I have no problem with that. It's a free, as I told you, invite everybody to attend except the viruses. Okay, don't invite. Okay, just let's keep all the viruses. Oh my God, away from us. Okay, thank you very much for coming today. I have a class this afternoon with the surveying. Seismic. I hope that the computer will not, or the internet will not turn me down like yesterday with the surveying group and also seismic group the week before. For some reason, system was shut down. I have no idea why. But today I do have a class at 4:30, from 4:30 um, to 7:30. If you'd like to come, if you are like to hear some seismic, I have 2 chapters left, chapter 15 and chapter 16 of my seismic book. So if you'd like to attend, you are very welcome to attend for free. This is the last session in our seismic today between 4:30 to 7:30. This is a seismic, and the ID for the seismic is 882-371-739. Oops, let me make my 8 like this is okay, like an Egyptian 8, but that's fine. So this is PM, by the way. This is Pacific Standard Time, California time. So this is the last session today. So you are very welcome to attend if you like to hear something about seismic. Okay. So thank you very much. I have to rush myself. I have to go right now. Thank you very much. Do your best, and I will do my best. I will do all my best to respond to your emails. Okay. And forgive me if I didn't come back to you immediately, but stay healthy and take care of yourself and your family, and pray for me. And I wish the best to all of you. Bye-bye.